Regression Analysis 4. More on statistical significance and other regression output. Which coefficients are statistically significant? We discussed in the last lecture that the ones with the asterisk were significant at the 5% level, but how did I know that? Well, there are two rules of thumb. One is that if the coefficient that the coefficient is statistically significant if it is double the size of its standard error. Let's go back. Okay, so this one is definitely double the size. This one is double the size. They're all double the size. Okay, so that's why it looks like they are statistically significant. Another way to look at it is if you have a t-statistic, if it's 2 or larger, if the value of the t-statistic is 2, at least 2, it will be statistically significant. And the way to look that up, more precise than the rule of thumb, is in your regression estimates output, there will be a p-value reported. The p-value is the probability that your coefficient is really 0. And if it's 0.05 or smaller, then you're pretty certain that your coefficient is not 0. And you can say that the estimate is significant at the 5% level. If the p-value is bigger than 0.05 but less than or equal to 0.10, then you can say that the estimate is significant at the 10% level. So you have another option for Table 2, which is that you can report the t-statistics if you like those better. So you can see that they're all larger than 2, much larger than 2. This table is a little bit different. It will be available to you as a Word document in your lab module. And for this one, the number of countries was listed down here. So it's really a style thing. Either one of these tables is perfectly good. And the two things are related, the standard error and the t-statistic. The t-statistic is the coefficient divided by the standard error. And that's why the rules of thumb are really the same, because if the coefficient is more than double the size of the standard error, then the t-statistic will be 2 or larger. And it's your choice. You can use either one. Okay, so the other stuff in the table, let's see what we have. We have a constant reported. We also have an adjusted r-squared. So what is the constant? Remember, the constant is the intercept. So that means you get the value of y if all the x's are 0. Okay? So if those terms, if the x's were 0, those terms aren't there, and y is just going to be the intercept. And this may or may not be meaningful, and that would depend on whether any of your x's are in fact 0. So if you're estimating something where sometimes there are people who have 0 values for x1, x2, and x3, then you could predict what their y value would be. In our data, though, there are no 0 values. Probably are not going to be any 0 values for the things that we're using for x1 and x2, so you don't need to really comment on the constant. All right, what about the r-squared? R-squared is a measure of how much of the total variation of your y variable can be explained by your x variables. In my table 2, the adjusted r-squareds were 0.40 and 0.42. So that means that the model explains 40% and 42% of the variation in life expectancy. So if I know your GDP per capita and I know the what was this one? How much effort you're spending on health. So what proportion of GDP is being used for health? I'll be able to explain 40% of the variation. And economists aren't terribly concerned about r-squared. I think in other fields it matters more. If you're trying to predict a stock price and you're a broker, that matters more. R-squareds of 10% or less are frequently reported in published reports, and no one loses any sleep over it. Economists figure that humans are so random that predicting even 10% of their behavior is pretty good. And that probably explains why we can't predict when the next recession will be. But even though we're not really sure about everything that people are doing, we do know that the coefficient, if it's significant, is telling us that if this rises, then all else equal, we're going to see a rise in the y variable. So we do have important information from our regressions, even if we're not explaining everything. Okay, why do I use the adjusted r-squared? As you add more variables to your model, the r-squared will rise. And the adjusted R-squared adjusts for the number of explanatory variables. So you should always use it when you're comparing models that have different numbers of explanatory variables. Next up, generating the regression estimates.